I'm now moving on to page 188 in your workbook. And for the questions on page 188, I need to find all intervals where the following functions are increasing or decreasing. All right, so for these kind of problems, we definitely need to take the derivative, set equal to 0, find the critical numbers, and then we're going to have to put our results on a number line so that way we can find all the intervals where we're increasing or decreasing. All right, so step number 1, I want to take the derivative, so y prime equals to, okay, that's going to be 6x squared minus 6x minus 12. So that's the very first step. You take the derivative, and after you take the derivative, you can factor out a 6 from all three of those terms. So 6 is my greatest common factor, and then I would be left with x squared minus x minus 2. Close the bracket, set that equal to 0. And then you'll notice that in the bracket here we can continue to factor that. So that's going to be 2 brackets, and I need 2 numbers that multiply -2, and those 2 numbers need to combine to -1. So -2 would work, and x plus 1 would be the final result. And then from this expression right here, that gives me a critical number of x equals to 2. And from this result, my critical number would be x equals to -1. So those are my critical numbers, and after I have my critical numbers, I want to create a number line. So here is my number line right here, and on my number line I want to put my critical numbers on there. So I have -1, and I also have 2. So these critical numbers right here, they would go on my number line just like that. And after that, you could definitely write the derivative just below it if you would like. So my derivative was 6 times x minus 2 onto x plus 1. Now our goal is we want to find numbers in between these regions, and we want to find numbers and plug them into our derivative and see whether the result is positive or negative. So if I'm in this blue region right here, I can pick a number like -10. -10 is definitely in that blue region. If I plug a -10 over here, if I plug a -10 back into my derivative here, you'll notice that the 6 here is now going to be positive. -10 minus 2 is going to be negative, and -10 plus 1 is going to be negative. So if you think about this, positive times a negative, that will give you a positive result. So this whole blue interval is going to be positive. Okay, let me just erase that. And erase this stuff now. Now in this yellow region right here, the obvious number that you should pick in the yellow region here is probably going to be 0. So you're going to plug in 0 for all the x values here. So let me just kind of erase this over here. Okay, so that's going to be 6, and then 0 minus 2, and then what's happening here is I have 0 plus 1. Now I don't care about the results, I just care that this 6 is going to be a positive, this result is going to be a negative, and this result here is going to be a positive. So if I take my positive and my negative and my positive, if I multiply all that out, the final result should be a negative answer. So that yellow region is going to be all negative. Okay. And then finally, I need to find a number in my green region, and a very good number in this green region could be the number, I don't know, 10. So now we're replacing 10 with all these x's. So I have 6 onto 10 minus 2 and 10 plus 1. And I don't care about the result, I just care whether the results are positive or negative. 10 minus 2, that's going to give me a positive result. 10 plus 1 is positive. So positive times a positive times a positive, well, that means the green region will give me a positive result. Okay, after that, let me just erase all this, and now I can jump to my conclusion here. This blue region has all the positive signs, so I'm definitely increasing in that blue region. So that blue region represents x is less than -1. I'm also increasing in this green region, so that means x is going to be greater than 2. So those are my areas where, the regions where I'm actually increasing. And you'll notice in this yellow region, that's where I had the negative signs. That's where I will be decreasing. So I'm decreasing when x is between -1 and 2. So I'd put my x in the middle, and my signs will point to the left. So here are my answers right here for that particular problem. Okay, let's move on to the next one. All right, so for this next particular question, I need to find the intervals where I'm increasing and decreasing. So I need to find my critical numbers to start. So I noticed that I have two functions here. So I need to use the product rule right here. So the derivative of x cubed is 3x squared times by the second term, which is e to the power negative x, plus the first term, which is x cubed. And then I would multiply that by the derivative of the second term, which is e to the power negative x, times the derivative of my power right there. So the derivative of negative x is -1. All right, so I'm going to make that equal to 0, and I will go ahead and just simplify the right-hand side. And the only thing I can really simplify is this positive and this negative sign. Positive times a negative would give me a negative result. So that would be x cubed times e to the power negative x. And then I'll notice that both of them have this common term of e to the power of negative x, so I can factor that out. So I will factor that out over here. And then you'll notice that there's an x cubed and an x squared. So the maximum number of x's that I can remove is x squared. So that right there, x squared times e to the power negative x, that's my GCF. So I'm going to factor that out. And if I factor that out, I should get a 3 minus x. And that works out quite nicely. And then I need to find my critical numbers here. So I need to take this expression right here and this expression right there, and I need to set both of those expressions equal to 0. So that goes to 0, and this also goes to 0. Well, the second term is much easier to solve. That just gives me x equals to 3. That's one of my critical numbers. And for the next one here, you have to remember that this exponential functions never have an x-intercept unless you have a transformation there. So in this case, there is no transformation. So this exponential function does not have an x-intercept. So I can just skip to x squared equals to 0, and that gives me a result of x equals to 0. So those are my critical numbers right there. And after that, I need to create a number line, and I need to put those critical numbers on the number line. So let me just create some space over here, and here's my number line here. And on my number line, I'll put my critical numbers of 0 and 3. So this critical number is there, and that 0 is that one right there. So I put my critical numbers there. And after that, you would do your best to write out the derivative on your number line. So my derivative, which was y prime, that equals to x squared times e to the power negative x bracket onto 3 minus x. So that was my derivative expression, right? And now the goal is you want to find numbers in these regions, in the yellow region, the blue region, and the the green region, sorry. You want to find numbers in those three regions and plug them back into your derivative. So, you know, a number here, you can a number in the yellow region that you could try is -10. A number in the blue region that you can try is probably 1, and a number in the green region could be maybe +10. And you want to plug those numbers in there and see what happens. If I take this 10, if I plug it into here and there, if I take that 10, if I plug into this expression right here, that just gives me a positive result. And then if I take this 10 and plug it over there, 3 minus 10 gives me a negative result. So a positive times, if I take this positive and times it by a negative, positive times by negative is negative. So that means the green region is going to be negative. All right? And that's how you would evaluate this problem using the number line. After that, you take the 1 and plug it in here, plug it into this term here. So that would give me a positive result. And if I take that 1 and plug it in there, 3 minus 1 is 2, which gives me a positive result. Positive times a positive is positive. And then finally, if I take this number here, -10, if I plug it in there, if I take -10 and plug it in there, -10 squared, that gives me a positive result. And -10 over here, that would be 3 plus 10, which would also be positive. So a positive times a positive is going to be positive. So this whole region here is going to be positive. Okay, so after that, I can now just evaluate the number line. So I'm increasing. I'm definitely increasing in the yellow region. So the yellow region is x is less than 0. And I'm also increasing in the blue region, and the blue region is between 0 and 3. So that's how you write that, between 0 and 3. And I'm decreasing in the green region, and in the green region, that's when x is greater than 3. So those are the regions where I am increasing, and those are the regions where I am decreasing. Okay, let's move on to the next problem here. Question number 6. So h of x equals to x cubed times ln x. So just like the previous problem, it looks like I need to use the product rule right here. So let's go ahead and find the derivative. And the derivative of the first term is going to be 3x squared times ln x plus the first term, which is going to be 3x, which will be x cubed, times the derivative of the second term, which is 1 over x. Okay, so I'm going to set that equal to 0, and that's going to be 3x squared times ln x plus, now that cubed will cancel off. That'll give me a 2, and that x will cancel off there. So now I'm left with plus x squared. Okay, and then from there, you'll notice that I have a common factor here of the x squareds. So the x squareds can just factor out, and that would give me 3 ln x plus 1, and that equals to 0. Okay, so after that, I'm going to highlight this part here in yellow and this part here in blue, because those are the terms that I need to set equal to 0. And algebraically, I need to solve these two expressions now. The first one's a bit easier. That's just simply going to be x equals to 0. On the next one, the 1 can go on to the other side, giving me 3 ln x equals to negative 1. And then I can divide both sides by 3. And now I will have ln x equals to negative 1/3. And in order to get rid of this ln right here, I need to raise both sides to the power of e. So the e and the ln, those will cancel off, giving me x equals to e to the power of negative 1/3. All right, so that right there, that's kind of looking like my critical numbers there. So my critical numbers are 0 and e to the power of negative 1/3. Okay, the next step now is I need to create a number line here. So let's go ahead and create a number line here. My critical numbers were 0 and e to the power of negative 1/3. Now, if you don't know too much about e to the power of negative 1/3, you can put that into your calculator and you should get 0.7165 approximately. And one more thing that I want to note here is that the original problem was x cubed times ln x. That's your original problem. And the domain for a ln function always happens when x is greater than 0. So this blue region right here, that's the part that's less than 0. We don't actually care about this part. And that's because the graph just doesn't really exist in that region. So the only regions that we're actually interested in are the yellow region here and this blue region right there. So those are the numbers that we want to test. Those are the regions that we want to test to finish off this problem. And remember, we are substituting numbers back into the derivative, which was x squared bracket 3 ln x plus 1. It's always best to use the factored form of the derivative. Okay, the numbers that you could try to finish off this problem could be maybe like 0.5 and maybe, I don't know, like maybe 10. Yeah, maybe that will be okay. If I take 10 here, if I plug it in there, that would give me a positive result. And if I take this 10 and plug it over there, that will also give me a positive result. So positive times a positive is going to be positive. Okay, so that's one part of the question now done. Let me just erase that. All right, after, let's take this 0.5 and plug it in there. That gives me a positive value there. And if I take my 0.5 and plug it in there, this is where it gets a bit tricky here. This actually will give you a negative result. And I would actually verify that with a calculator. The reality is, whenever you make small numbers in here for ln, you actually start getting some negative numbers. So ln of very small decimal numbers like 0.5, those will actually give you some negative results. All right, and in order to finish this off, we have a positive times a negative, and a positive times a negative gives you a negative result. So this region here would strictly be negative. Okay, let's finish this question off. Let me just erase these lines here. So I'm definitely increasing in the blue region, and the blue region represents values where x is greater than e to the power negative 1/3, and I'm decreasing in the yellow region because the yellow region has the negative sign. So that happens when x is less than e to the power negative 1/3, but it's greater than 0. So let me just apologize. That yellow region is between 0 and e to the power negative 1/3. So let's write that inequality like that. Let's just sandwich it like that. And that is your decreasing region, and this is your increasing region. Okay, before I finish off this homework video guide, there's one more question in your workbook. I believe it was question number 4. I'm not sure if it's question number 4 or 3, but the problem was y equals to x plus 2 cos x. And I want to focus on the interval between 0 and pi, and I want to find out where the function is increasing and decreasing. And I think this is a great question that you can try. You can definitely try with the calculator just to kind of confirm your numbers here. And it's also another great practice question here that we'll definitely do in class as well. But let's go ahead and do this question as well. I would start off by doing y prime. And the derivative of x is 1 plus, this is a constant, so the constant remains. And the derivative of cos x is going to be a sine x. Sorry, it's not sine x, it's negative sine x. So let me just write that down as negative sine x. So this would now be 1, sorry, my pen's not working, 1 minus 2 times sine x. So 1 minus 2 times sine x equals to 0. And then if I went ahead and solved this, I would get 2 sine x on the other side equals to 1. And then I can divide both sides by 2. And now I would get sine x equals to 1/2. Now this part right here, sine x equals to 1/2, there's a few ways where you could solve that. And here's one way where you can actually think about sine x equals to 1/2. You can actually draw the graph out. And let's just say this is 1/2. If I just drew a horizontal line and went across the graph of sine x, the values that give me, the x values that give me 1/2 are actually pi over 6 and 5 pi over 6. So my solutions here would be x equals to pi over 6 and 5 pi over 6. That's one way that you could kind of think about that particular problem. The x values where sine x equals to 1/2, just draw the graph. Now, if you're not really familiar with the graphs, the other thing that you could do is you could use the unit circle and one of the trig ratios. So this is actually coming from the special triangles here. So this is pi over 3. This is pi over 6. So this is the ratio of the 30, 60, 90 triangle. And this would be root 3. The hypotenuse would be 2, and this side would be 1. And if you think about sine of pi over 6, sine of pi over 6 is the opposite and the hypotenuse, so that gives you 1/2. So sine of pi over 6 gives you the 1/2. That's how you get that answer right there. And if you think about the cast, because this ratio sine x equals to 1/2, since that's positive, sine is positive in quadrants 1 and 2. And if you draw another unit circle right here, basically the answer in quadrant number 1 is right here, pi over 6. That's one of the answers. The other answers would be in quadrant number 2. So you're going from here to here, and this part right here is pi. So in order to get this red that red angle there, or that red distance, it's really, you're taking this pi and you're subtracting the pi over 6. So pi minus pi over 6 is 5 pi over 6, which gives you that answer right there. So there's different ways where you could solve this equation right here. You can look at the graph, or you can draw yourself a triangle and construct the unit circle using cast as well. Okay. Anyways, those are some ways where you can get the critical numbers there, which were pi over 6 and 5 pi over 6. After that, let's go ahead and draw the number line. And because the domain of this graph is between 0 and pi, let's put 0 and pi there. And let's go ahead and put in the pi over 6 here, and the 5 pi over 6 over there. And let's go ahead and write out the derivative here, which is y prime equals to 1 minus 2 sine x. Now from here on, here on outwards, I would just recommend using a calculator and just doing this as an exercise here. Pi over 6 is the same thing as 0.52 roughly. And 5 pi over 6 is about 2.617. And everyone knows pi, that's about 3.14. So now you want to find numbers in these regions. And you want to plug those numbers into the derivative, which is over here in purple. Okay, so a number over here that we could pick is maybe, I don't know, 0.25. And if I plug that back into here, if I do 1 minus 2 times sine of 0.25, and if you just insert that into your calculator, you will get a positive result. So this whole region here would be positive. All right, and then over here, here you could pick a number such as 1 perhaps. 1 is definitely in the blue region. If you plug in 1, you'd get 1 minus 2 times sine of 1. And if you plug that into your calculator, that should be less than 0. So this whole region is going to be negative. And then finally, we can pick a number in the green region. A number there could be like 3. So if I plug that in there, that'd be 1 minus 2 times sine of 3. And that would give you a positive result. So this whole region is positive. Great. And then after that, I know I'm kind of rushing a lot of the questions in this video just because the questions are very long. We can finish off with a final result here. We're increasing when we're between 0 and pi over 6. That's the yellow region. And we're also increasing in the green region, which is between 5 pi over 6 and pi. And finally, we're decreasing in the blue region, which is between pi over 6 and 5 pi over 6. Now we're 99% done this problem. The only thing that I want to add for this particular problem was the domain. Now where was the domain was between 0 and pi, right? So since the domain is between 0 and pi, just kind of finish off this problem, we should have the equal signs on 0 and pi. So we definitely highlight those just to emphasize those guys. That's the last thing you would do to kind of finish off your particular problem there, and that would be it.